So now we'll look at the types of hypotheses we study. The first type is called the Null Hypothesis, Null, N-U-L-L, and this is about the established population value for the parameters. Remember, we use mu, p, and sigma for the mean, proportion, and standard deviations of the population. But the key here is it involves strict equality. The symbol for the null hypothesis is H0. So a subscript of 0, N-A-U-G-H-T, is referred to as H0. And since it involves strict equality, it will always be using just an equal sign. If we're not looking at the null hypothesis, then we are looking at the alternative hypothesis or the alternate hypothesis. And this is a claim about the established population value for a parameter. Usually it's a challenge, but remember it could be in support of. And we use the subscript of a 1, so H1 is the alternate or alternative hypothesis. And because we're using inequality, we use symbols of inequality such as not equal to, less than, or greater than. We don't use less than or equal to, greater than or equal to, because that has some equality to it. So here's some examples where I've just listed all three together, but here this first one is an example where we're challenging a population mean. We still always list H0 and H1. H0 has equality in all my examples because that's always true, and then I have some form of inequality in the alternate or alternative hypothesis. And notice whatever number is used in H0 is always used in H1. So like in our Coke example, we would be using a 12 here because that's the population established value. And that's kind of what this first line is saying. The population standard deviation is 1.7. Somebody's claiming that it's actually greater than 1.7. And then the other thing is to talk about tailed tests. So what ends up happening is this first type, when we have equal and not equal to, is a two-tailed test. When we have equal to and less than, we'll have a left-tailed test. And when we have equal than or greater, equal to or greater than, we will have a right-tailed test. And the way you can remember it is if you kind of think of that less than symbol as like a left arrow. Oh, sorry, these are one-tailed tests. Then the less than symbol is going to be a left-tailed test. Since the greater than symbol is pointing to the right, it's going to be a right-tailed test. And then for the not equal to, if you've ever noticed, there's not a not equal to sign on the keyboard when you type. And in computer language, if you have to type in not equal, you use the less than and greater than in opposite directions. And in this case, that kind of helps because it's like an arrow pointing in both directions. So I have two tails. So now we're going to look at finding H0 and H1, the null and alternative hypothesis. So first thing I usually like to do is determine what parameter I'm going to be using. Is it mu, p, or sigma for the mean, the proportion, or the standard deviation? And then I usually determine whatever that population value is that goes with it and put it in both spots. And then next I will determine the equality or inequality for the claim and insert that with the correct spot and determine whatever symbol I need for somewhere else if I need another piece. So let's look at a couple examples. So the first one says, the age of a community college student is 26 years old. A history teacher claims that the average has decreased. So it starts off with the average age of community college. The teacher claims that the average has changed. So clearly I'm working with mu. So first thing I did is decided what parameter I was working with and inserted that. So next I want to figure out what that population value is. So as I read it, it says the average age is 26. That's my fact. So I need to put equals 26 for the null hypothesis. And if it's 26 with the null, then it's going to be 26 with the alternative, and I can just put 26 right below it. And then as I read it again, it says, a history teacher claims that the average has decreased. So for decrease, we're using less than. which goes in H1, so I need to put that symbol in my H1. Ultimately, I've done everything I need to find null and alternate hypotheses. The only other thing we do is a lot of times I'll write the word claim or a C off to the side, because one of the things we'll need to know later on was the claim about the alternate or about the null hypothesis. So putting this little note here while I'm freshly thinking about the problem, I don't have to go back and do it later.